Good afternoon, or good morning as it may be, and thank you to everyone for joining the webinar today, presented by Trustgrid and Amazon Web Services. In today's webinar, we're going to be discussing how to get started deploying fintech applications in AWS, and in this presentation, we're going to be discussing some of the more important choices to be considered when planning such a deployment. Today's presenters will include yours truly. My name is Steven Stites. I'm the CTO for Trustgrid. Also presenting will be my partner in crime, Joe Gleinzer, the Chief Product Officer for Trustgrid. And also joining us today is our friend, AWS Solutions Architect, Kevin Wall, who will be helping us dig down into AWS security architecture. So to set the stage a bit for this conversation, I'd like to start with a good quote from Lou Sanko, CIO of Q2, one of Trustgrid's biggest customers, who said, "The online branch is now the most important branch for banks." So we find ourselves in a time where banks and credit unions are really beginning to embrace cloud applications, not only to offer their own online and mobile banking applications, but also a variety of other fintech services. This relatively new enthusiasm for cloud-delivered fintech apps has given fintech providers the green light to move their applications to the cloud for some of the same reasons that other application providers have, including a lighter management burden and greater flexibility to scale the application infrastructure as their customer base grows. So the result of all this is that not only do we have an explosion of fintech apps that are starting up in the cloud, but also have many providers that have existing brick and mortar relationships that are either currently or soon plan to move their applications to the cloud as well. But many of these providers find themselves lagging behind in these migrations and struggling to keep up with new competitive offerings that are popping up. So what this means, the market size for these fintech apps is growing. More and more application providers and offerings are capturing more and more financial institutions' spend as FIs need to increase or improve their offerings to remain competitive. The share of this wallet is shifting. That increased FI spend is being divided up and distributed in different ways among more players and offerings in addition to the banking core provider. And last, we have an explosion of fintech startups that are really challenging the incumbent providers and forcing them to take action and plan their own migrations to the cloud for the reasons I mentioned previously. As an example, Aperture, a fintech provider and Trustgrid customer, just recently shifted 100% of their existing application data center footprint to AWS infrastructure. So why the delay? There are many reasons, and let's go through them. So first, many providers need to overcome a large install base of on-premise hardware and software installs. Next, cloud delivery can change the business model, and this obviously is something that really needs to be thought through. Also, providers can have a large existing investment in data centers, and it can be difficult to untangle themselves from these investments. When making this move, rather than lift and shift the existing applications, most providers would like to use this opportunity to try new architectures and take advantage of new technologies when they make this change, and this takes time. Providers will likely find themselves with skill gaps in new key areas, such as cloud infrastructure and platform management, development and support tools and processes. Compliance concerns. Giving up control of their infrastructure can give rise to these kind of concerns, both from the provider and some of their customer base. And these concerns need to be investigated and ultimately put to rest. And last, the provider's application relies on core banking data that will not be moving to the cloud. And so to recap, a cloud migration is necessary, but also presents challenges. So let's discuss what some of these look like. Many things to consider, and we're going to step through these one by one. So first, is the provider ready for and who will lead the DevOps transformation of their organizations and processes? How long is such a cloud migration going to take? As we all know, it's very hard to estimate such large projects like this. What will be our compliance stance and messaging to our customers as we begin to move these customers to the public cloud? What will new security architectures and processes look like? And this is typically going to require a lot of education of teams on existing best practices. Costs. How much is this migration going to cost us now, and what is it going to look like going forward after this huge change? And perhaps the most important of the application, how are they going to continue to integrate with their customers' legacy systems that they are using today? And last, as we can see in the middle of this slide, there may be additional unknown unknowns that will be found along the way. So obviously, there are a lot of things that need to be figured out when making this journey. One of the items the previous slide mentioned is the transformation to a DevOps delivery model. And I wanted to call out a few things that can make this a difficult process. First, the organization is likely moving from an older software delivery model to a new CI/CD model and processes, which can be greatly facilitated by the tools of an infrastructure provider like AWS if you take advantage of them. Next, a new blend of staff skills will likely be needed, breaking out of organizational silos and beginning to blend development, operations, and security skill sets as these providers try to shift left their delivery model. Developers will also need knowledge of and access to infrastructure in ways they didn't before. In order to properly help operate and support the applications, they will require new observability and troubleshooting tools. And last, all these changes in systems, people, and vendors all need to be in sync. So now I'd like to shift the conversation over to the security and compliance considerations I mentioned previously. So at this point, I'll kick the conversation over to Kevin.
Okay, thanks, Stephen. So when we first start talking to customers and help them understand the AWS security model and the services and features that are available, the conversation often starts with the challenges and the pain points that they're having and the requirements that they have to move to the cloud. And the conversation usually falls into a high level into one of these three categories. And the first one being, how do I do security in the cloud, and how do I properly protect my data? And whether you're new to the cloud or you've been with the cloud for some time, these conversations continue to happen and continue to iterate as new features and new services are released, as new security technologies and new encryption protocols are released. And there's always new threats and new risks that are being presented to the organization. So this is always an evolving conversation. And then second, we start talking about moving from this concept of a legacy or on-prem service into the cloud. And so that usually comes in multiple components and multiple pieces. Often organizations will have some type of security appliance, and whether this is a virtual or a hardware appliance, this serves a key piece of their security infrastructure. And this could be for firewall or for a NAT appliance. It could be something more messaging like anti-spam or antivirus related. And many of the top vendors that organizations work with have already started moving to the cloud, or have already moved their service to the cloud and provide it as some type of software as a service type offering, or some type of Amazon machine image that could be obtained and deployed into the environment. And then lastly, we're being asked by security teams about how they enable their IT operations teams to be really the front line for security. So it's no longer acceptable to see security as more of this kind of retroactive thing where you're looking at logs afterwards and resolving something. Threats today require that you be much more proactive and real time about monitoring what's going on in the environment, being able to properly classify that risk, and then being able to quickly respond to it and mitigate it. And so now we start talking about what are the benefits of security on AWS, and how does it address some of these trends? And the first one being that there's a very comprehensive set of services that are available. And so this isn't something just from like an infrastructure security perspective, like using Amazon's web application firewall, but also having things like DDoS protection with AWS Shield, having data encryption with AWS Certificate Manager and key management services, having a monitoring and logging capability. So these are services like CloudTrail and CloudWatch, and then finally having this underlying identity and access management control for all of those services, and being able to properly provision provision these services within your environment. Second, having this scalable nature. A lot of the things that we do within AWS have this scalable nature, and especially from a managed service capability. And so, just like an application in your environment, you want to make sure that your security environment, your security solution can have this ability to be in this kind of scaled down state when the threat is low, or the requirement for that security solution, maybe users coming in through a VPN, the number of users are low, and as that usage scales up, or the risk or the potential malicious activity scales up, you need your security solution to scale up as well. And so that's a very key part of our managed services. And if it's not a managed service and it's using some of the underlying compute technology, then you can use the default auto scaling and the services and put those behind load balancers. In terms of data protection, privacy, and data security, AWS has always been vigilant about customers' privacy and data security, and ensure that customers retain ownership and control of the content, and have the ability to encrypt it and protect it and move it and delete it when they need to align with their organization's policies. And then in terms of automation, having the ability to now take some of those security services and not just have a manual process for dealing with security threats, but having more of an intelligent, automated way of detecting threats and malicious activity and unauthorized behavior across your AWS accounts, and then being able to apply controls to just detect it and then also mitigate those risks. And so we have services like Amazon Guard Duty that have integration with Amazon CloudWatch to provide that type of automated detection and resolution. And then finally, there's this concept of an ecosystem. And one of the great things about the AWS cloud is that our customers inherit all of the best practices of AWS policies, architecture, and operational processes to help that were built to satisfy some of our most security-sensitive customers. So everyone gets to take advantage of those concepts. And so this leads us into this the concept of the AWS shared responsibility model. And if you look at kind of how AWS's underlying architecture is deployed, you'll see it has some of the same security isolations that would be found in the traditional data center. So we have physical data center security, separation of network resources, separation of server hardware, and isolation of storage resources. And so those same concepts apply within the AWS framework, and then the customers are responsible for building their secure applications on top of that. And we provide a wide variety of best practice document and encryption tools and guidance, but really where that model is supplemented in a very strong way is with our partner community that have their own set of tools across network security and configuration management and data encryption to really supplement that. So if you think about AWS as being security of the cloud, and then the customers are responsible for security in the cloud, and then partners kind of sit on top of that of being security on top of the cloud. And so it really gives you that full solution that you need. So yeah, another way of just looking at it, sometimes it helps to see different ways of picturing this model. If you think about here on the bottom, this is more like I was talking about the traditional data center of AWS managing the underlying compute and the virtualization layer and the underlying network communication, and then making sure that that communication happens across the different regions and potentially globally. And then the customers have the solution that sit on top of that, managing the actual operating system, applying the network traffic rules for how traffic should be routed, and then, of course, building their application on top of that and securing that. And so previously we looked at the infrastructure services. If we look at something like some of our abstract services like Amazon S3, Amazon DynamoDB, and Amazon Kinesis, it uses the same model in that Amazon is responsible for the underlying hardware and virtualization, but now these services are based on a host and based on an underlying operating system that's not exposed to the customer, but that AWS manages. And so now instead of the customer having to manage the actual platform and the operating system for these services, Amazon manages those components and then exposes it through endpoints. And then customers are responsible for the data that sits within these services and applying the appropriate encryption and protection of that data that aligns with their requirements. And then finally, just to talk about AWS Compliance. And so some of these reports probably look familiar to you. Some of them may not. Really, these are the reports that, these are your typical SOC reports or your PCI reports. Some of these are specific to an industry. Some of them are specific to a geographic region. The point being that if you need to present a report to some type of entity or to your own organization, you can go into AWS Artifact and obtain these reports and download these reports to show that the specific AWS service that you're working with aligns with the accreditation. And so now I'm going to turn it back over to Joe, who's going to show the planning process.
Great. Thanks, Kevin. So on to the planning and implementation considerations here. So we've got this broken down into 3 main phases to help you categorize the work in front of you. I think at this point in time, we can presume that everybody is excited and wants to move to the cloud. And this conversation will focus on specifically the how. Let's start with initial planning. The most important step of this process is going to be to identify the workloads that can be moved to the cloud effectively. And though our gut reaction might be to consider all workloads for migration, especially in the financial technology space, a lot of those workloads are not going to be easy to move. A big part of this reason is the adoption of technology by the banking industry in general, starting in the 1950s and 60s. Unlike many other industries that may be starting with more modern technology or recent applications, a lot of the applications in the banking space can be dated back to the 70s, 80s, and before. This is going to be a heavy lift to get that into the public cloud. There may also be some security or compliance concerns among pockets of your organization that prefer to keep some of this data or systems in-house. That said, there are easy workloads to get up into Amazon that should make for some fast wins and build some momentum for the project as it continues. The next step is to re-envision the architecture of those workloads. And we'd use some terms like lift and shift and refactoring. We'll talk about what those mean. A lift and shift is essentially a movement of your applications and infrastructure as they exist today, usually from physical or virtual assets into the cloud, with minor changes, if any at all. A refactoring of an application is taking it back to the code and looking at ways we can optimize that application to take advantage of Amazon's platform as a service features. The first, lift and shift, usually is the fastest and easiest method to get your applications to the cloud today, but the second is going to provide the best long-term value. And so you really have to trade off that initial investment in time and energy with refactoring to get a longer-term payoff on this. The most common path forward that we see is to lift and shift these applications early on, and as you build competency around the AWS cloud, to then embark on a refactoring and leveraging that new knowledge you have. The third and final phase here is the evaluation of vendors. And the cold hard truth is many of the vendors that were able to service your FI or your application provider in a private data center, in a private cloud environment, are just not going to make the cut when it comes time for public cloud. These may include third-party tools like monitoring or security appliances. It could also include service providers like MSSPs. And so you really want to take a cold, hard look at those vendor relationships you have right now and decide what's going to have to change to be successful in the cloud. The result of all of this is going to be a realization that you're moving some subset of your total workloads to the cloud, and you're going to wind up with an infrastructure that spans both AWS, your private data centers, and very commonly your customer environments as well. The next phase we'll talk about is the pre-migration phase. And this is the part where you can develop new cloud applications as you develop competencies in the cloud. These are the easiest wins to get for an organization, is to start from scratch with a new feature or service or component in the cloud. That would help you leverage the AWS platform as a service features most easily, and typically give you a real good exposure into the more advanced features and management skills required in this environment. Along with this, we'll deploy and validate those new services in the Amazon environment, and then we can address organizational security and compliance requirements, typically in preparation for your SOC audit or FFIEC audit, and for the first time go through AWS's artifact tool that makes it very easy to accommodate the documentation requirements of a modern a Fintech application. Finally, the migration process, whether you're lifting and shifting or you're developing new applications, it's very important to consider the communication phase. If you're working with the community FIs around the country, you're likely to encounter some resistance within those customer environments to the cloud, some uncertainty around what the cloud actually is, as well as a need to really plan the cutover phases to emphasize those early adopters that'll be a little more bold than the rest of your customers. This is also true internally. You're likely to find some resistance inside your own organization to the public cloud, and need some additional time to really invest in making sure that those individual stakeholder needs are addressed as you start migrating workloads into the cloud. We say here that the initial planning to migration phase can take 12 to 18 months. In a full data center migration, at least most of a data center migration is commonly in that time frame. However, you should be able to get some easy wins and some early migrations in a matter of weeks to months as you move those high priority or easy to migrate applications or start some new service development in the cloud. So we talked about the reality of your applications spanning multiple infrastructures, public cloud, private cloud, your own data center, and your customer environments. And Trustgrid calls this the hybrid cloud environment. And this is the reality for most fintech providers who are set on moving to the cloud. You're not going to move everything to the cloud. There are going to be workloads that continue to exist in private clouds and customer environments. And the key to getting that application architecture right is connectivity. One of the most important decisions of your cloud migration is how you're going to maintain connectivity with the systems that can't move to the cloud today. Let's look at some of the common challenges of these hybrid cloud networks. First off, deployment times. We certainly will struggle with getting these circuits turned up, whether these are on-demand VPN or MPLS. We're going to have to address the configuration requirements both in Amazon that may require some subtly new skill sets, and with a variety of different endpoints on the on-premise networks. We'll have to address security and compliance in many cases outside of the scope of the AWS shared responsibility model, as this traffic will leave the AWS infrastructure. And then finally, worrying about the ongoing maintenance and support of these networks that may cross organizational boundaries and a variety of different types of infrastructure. Let's look at MPLS, probably the most common method historically to handle connectivity between data centers and users. MPLS is a well-known commodity and has been used in the banking industry for many decades. It provides a relatively low latency connection with good availability managed by internet service providers around the country. It is a private connection that serves to meet most of the needs of branch office connectivity around the country. Unfortunately, it is the most costly solution. Because of this, it's going to be difficult to scale this to many locations. It always takes months to provision, relying on the internal efficiencies of today's modern ISPs. And finally, MPLS is difficult to terminate in public clouds without dedicated resources and very advanced skill sets. Your IPSec VPN tunnels provide a good alternative to MPLS. They're secure. They terminate easily in public cloud using either native AWS features or with a variety of third-party next-generation firewall providers. They're much cheaper than the MPLS connection, they still have a complexity to configure in the cloud and on-premise that makes them a difficult choice. It does require extensive expertise on both sides of the network, and the support and maintenance burdens really become impressive as you scale the number of these VPN solutions. VPNs typically are great for a low volume of connections and a fast turnup time. Dedicated cloud circuits like Amazon's Direct Connect provide a very high bandwidth solution with a dedicated circuit directly from your data center into your Amazon environment. They achieve high throughput, they are fairly expensive, and the tunnel is not encrypted even though it is a dedicated tunnel for your environment. You may use third-party products like Trustgrid to add encryption here. Some of these are difficult to deploy in on-prem environments, and you might find that your data center does not have a direct connect solution available from your ISP. Finally, the most modern of these solutions, software-defined wide area networking, solves many of these challenges. It blends the benefits of VPN along with the management capabilities of the cloud. Amazon, at its nature, is software-defined infrastructure, and the benefits that you're driving at within the Amazon public cloud environment are derived from the software that automates much of the management burden that was common in private cloud and on-premise data centers. When you combine Amazon with a software-defined networking solution to meet your hybrid cloud connectivity needs, you get the best of both worlds. So what is software-defined wide area networking, or SD-WAN? SD-WAN enables a network to be created, controlled, and supported by using software. This might not seem like much of a leap, since software has been driving all of networking since the very beginning of Cisco routers. However, that represented a unique combination of hardware and software engineering that left you very dependent on the hardware itself. This made the technology slow to change, difficult to manage, and introduced substantial security vulnerabilities over time. Software-defined networking is a much more flexible and agile solution that runs on out-of-the-box hardware, is able to leverage modern operating systems like Linux, and allows you to embrace a rapid pace of change to support advanced features. This enables the network to be managed much like your cloud environment and achieve the same goals in the wide area network that connects your hybrid cloud resources to your public cloud environment as you achieve in Amazon. Trustgrid is an SD-WAN Fintech application providers. Along with our early customers, Q2 and Aperture, we engineered the solution to meet the specific needs of the Fintech community as they engage with community banks around the country. Let's look at some of these specific challenges. The first is limited or unpredictable on-site resources. As we move around the country and talk to credit unions and banks, we find a few realities. Some smaller banks and credit unions outsource IT and are dependent upon the availability of a third-party provider. Other large credit unions with large IT teams and advanced skill sets are burdened with a large project load and have it difficult making time to handle hybrid cloud connectivity needs of their software vendors. The deployment times can really get in the way of turning up a new FI that has decided on becoming a customer. New VPN connections, and especially MPLS connections, can take months to activate and even longer to get the security and configuration right to start using it. This next item is unique to the fintech industry because so often they connect multi-tenant applications to their customer environments. The connecting of different organizations using modern network technology introduces a variety of networking, security, and compliance challenges. And finally, when fintech application providers connect to dozens, hundreds, or thousands of customers, the maintenance and support burden is difficult to manage, requiring large dedicated teams with advanced skill sets. Trustgrid solves these challenges by leveraging plug-and-play connections that make deploying the appliance on-premise as easily as plugging in a cable modem. Just connect power and Ethernet, and you're ready to go. Our smart configurations can be deployed as virtual appliances or off-the-shelf hardware appliances using typical hardware to divorce the custom hardware requirements of yesterday from the modern software solutions of today. We standardize all cloud to on-premise connections in a new virtual network overlay that eliminates the complex NAT translations required for yesterday's VPN connections. And finally, Trustgrid delivers a single pane of glass that automates management and provides visibility across all of your nodes deployed. The closest comparison to a Trustgrid and other SD-WAN solutions are legacy IPSec VPN solutions. Let's take a peek under the hood and see how they compare. With Trustgrid, we get one-touch plug-and-play connectivity for new tunnels and devices. IPSec VPNs typically rely on next-generation firewalls that can be difficult to configure and require specific firewall rule set changes to work. Trustgrid can eliminate the need for on-site IT to be heavily involved in these deployments, whereas IPSec VPN will require advanced skill sets from your customer environments and within your own team. One of the largest challenges that Trustgrid customers face is the patching and updating of the devices once deployed in their customer environments. Trustgrid automates this to patch to the OS and application level without any involvement from our customers. IPSec VPNs typically rely on either dedicated devices in their customer environments with a manual patching process, or turn the responsibility over entirely to their customers with mixed results. Trustgrid delivers a high availability solution leveraging clusters of Trustgrid nodes on premise and enables multi-data center and multi-region failover within Amazon automatically. For IPSec VPN, achieving this typically relies on a combination of advanced device features and BGP, which is a whole different level of complexity and requires a much more advanced skill set to deploy and maintain. Trustgrid simplifies the network address translation issues that are common when connecting between organizations. These RFC 1918 subnets, the private IP spaces, are typically reused among customers and their vendors without any pre-planning. This creates a difficult problem to solve that Trustgrid has handled with our virtual network overlay. With IPSec VPN, you'll be making one-off decisions for each FI that will result in a mess of spreadsheets and difficult management processes at scale. So how is it done? Trustgrid integrates with Amazon's Transit Gateway and Transit VPC to solve some fundamental networking challenges when you connect your cloud applications to your on-premise environments. Amazon's Transit Gateway, announced last year at reInvent, allows you to connect your production and test VPCs to a single VPC per region called the Transit VPC and terminate all of your Trustgrid or VPN connections or direct connect into the Transit VPC. This allows seamless connectivity from your application to the on-premise applications and datasets. Transit Gateway solves a challenge that previously was difficult to overcome and required the deployment of a large number of network appliances within Amazon. It connects those VPCs through a Transit VPC to an on-premise network. It scales easily across regions, and it simplifies the network configuration requirements for your application. Trustgrid nodes are deployed in the Transit VPC at the edge of the Amazon network. Trustgrid Edge nodes deployed in customer environments build outbound TLS tunnels into the Transit VPC in each region. This enables seamless connectivity from those VPCs hosting your production and test applications through the Transit VPC and to the customer environments. To deploy Trustgrid for a new FI is a fairly simple matter. An Amazon machine image is deployed in Amazon using the Transit Gateway service. Trustgrid then helps the application provider select secure off-the-shelf hardware, and we deploy it pre-configured to the FI. Once connected, the device phones home automatically, builds the tunnel without any additional configuration, and connects to the application's cloud environment. The connection is secure and highly available, and it's always established from the customer's environment outbound to the cloud. Trustgrid has proven this model with some of our largest customers, Q2 eBanking, and Aperture. The costs of this solution are important to consider up front, as it represents a large departure from the way that costs were previously considered. Your private data centers are typically capital expense heavy solutions requiring large upfront investments, requiring advanced skill sets, and a lot of time to get up and running. Amazon has changed the game when it comes to these costs. Amazon provides a pay-as-you-go method that allows you to easily scale up in costs as your usage increase. The tools are simple to manage and maintain and allow you to focus your advanced skill sets on the more difficult challenges at hand. The costs are essentially the compute required, your processor and other load from applications, the storage you need, the bandwidth that will flow through your transit VPC, and your Trustgrid SD-WAN solution. So how do you get started? What might seem like an overwhelming task really can be broken down into a few simple steps. The first are to establish your realistic objectives. As we referenced earlier, you're going to wind up with a hybrid cloud deployment in most cases. Understanding that from an early stage will keep the project from running away from you. Get those reasonable objectives established, achieve some early success, and tackle the hard lifts later. Selecting your team is an important part of the process. Most of our customers, as Stephen mentioned earlier, are transitioning from a legacy IT approach relying on dedicated operations and support staff into a DevOps approach. Typically, advanced training is required to pull this off, along with new tool sets. And finally, setting those priorities. It can't all be done at once, and this will be a long-term project that will benefit your organization for many years to come. I'd like to welcome you at any time to talk to a specialist from Trustgrid, ask questions, or Amazon, and help you get your cloud migration project underway. For Stephen, for Kevin, we'll wish you thank you, and I appreciate your time today. Goodbye.